Hello, my name is Mark Segal, and I would like to talk to you about the Beaconless Active Meteorological Sensor, or BAMS system. BAMS is currently under development by Intellisense Systems as part of a Navy SBIR contract. Intellisense Systems Inc. is a leading provider of advanced sensing and display solutions, supporting a data continuum from acquisition to visualization. We enhance our hardware with software that adds intelligence to our systems and can turn raw data into useful information for improved decision-making and process automation. We are a technology innovator and advanced systems integrator that solves some of our customers' toughest challenges by designing, developing, and manufacturing solutions that sense, transmit, process, and display information. Our core capabilities include environmental sensors, displays and avionics, and artificial or augmented intelligence software solutions. As a company, we strive to create value for customers by providing a variety of capabilities that improve situational awareness, decision-making capabilities, and safety. We offer both off-the-shelf products and custom development services with our current products, such as the Micro Weather Station, being developed from SBIR contracts to directly meet the DoD's needs. Headquartered in the South Bay area of Los Angeles, our facilities occupy over 80,000 square feet. Our manufacturing capabilities include electronics fabrication, unit qualification testing, systems integration, and volume production, with full quality assurance to serve both government and commercial customers. We have the agility of a small business that can provide timely and innovative solutions to our customers, with the stability of an established corporation that can support the entire technology and product development lifecycle. The BAMS system is being developed by Intellisense to address the Navy's need for an advanced meteorological sensor that can simultaneously measure several atmospheric properties and characterize the marine wave boundary layer. The Navy's requirements for such a sensor include being able to measure the atmospheric path-integrated optical turbulence parameter, temperature, pressure, and humidity at measurement ranges of greater than 5 kilometers and survive in a marine environment. The system should also utilize a monostatic, beaconless design. Such a sensor is particularly useful as an adjunct for military systems that require atmospheric monitoring for optimal performance. Related to this, BAMS offers atmospheric feedback to support a variety of mission operations. It will enable accurate models of the marine wave boundary layer to be generated, thus supporting meteorology, oceanography, and atmospheric propagation model development. As a beaconless system, it does not require the deployment of an auxiliary device, thus minimizing overall measurement times and eliminating the need to clear the area after the measurements are completed. The technology can be mounted to naval platforms, land vehicles, manned aerial platforms, and stationary terminals as desired. Now let's talk about the details of BAMS. It's a beaconless LiDAR system with support for spectroscopic measurements of the atmosphere. It measures the local turbulence parameter in overland and marine environments, supports operational ranges greater than 6 kilometers, and utilizes a monostatic, beaconless design. Tests of the system demonstrate that it provides measurements consistent with other atmospheric characterization systems, and it supports Raman spectroscopy via a 3-band laser to measure the atmospheric temperature, pressure, and humidity. The total measurement latency from laser activation to the display of the results is less than 6 seconds. The system weighs 198 pounds, occupies a 6.2 cubic foot volume, and is wall plug powered, though it should be noted that the size, weight, and power consumption are not yet optimized. It should also be noted that the component layout shown here can be adjusted based on the platform needs. So, what specifically gives BAMS an advantage relative to existing atmospheric sensors? First, because it measures multiple atmospheric parameters simultaneously, it enables the complete characterization of the marine wave boundary layer. Its beaconless design allows for rapid atmospheric characterization without deploying a secondary device. This is particularly ideal when deploying a secondary device may not be practical or possible. Its measurements support accurate oceanographic modeling, and the device can be seamlessly integrated into atmospheric monitoring subsystems for related military systems, thereby expanding the capabilities of those devices. The hardware itself is environmentally rugged and supports a reconfigurable layout for compactness, which allows BAMs to be modified for incorporation into a given platform. Light can be carried to and from the emitting and receiving components using optical fibers, if needed, thus minimizing the size of the elements that need to be placed near windows or viewing ports. In terms of development status, Intellisense is currently fabricating and testing multiple iterations of the developmental prototype under the Phase 2 effort. The initial prototype, which only measured the atmospheric turbulence, was tested in a marine environment in the summer of 2024. The full-scale prototype, which measures all of the atmospheric parameters, will be field tested in the late summer of 2025, at which point the technology will reach TRL 6. After these field tests, we will focus on integrating the technology with an initial platform, where we can reach TRL 7 and beyond. In terms of transitioning the technology to the fleet, the next major milestone is demonstrating the full-scale BAMS prototype in a relevant operational environment. We then plan to begin integrating it into a platform agreed upon with the Navy as part of either a Phase 2S or a Phase 2.5. We expect that the first fully productized system will be available in 2028, which will be implemented under NAVC 073. In terms of its commercialization applications, we note that BAMS is relatively platform agnostic and can be integrated into most meteorological sensor packages. We estimate that a productized system will cost on the order of $240,000. The primary commercial market for BAMS is the automated weather observation market. This market has more than 900 automated surface observing systems and more than 650 automated weather observing systems in the U.S. Even assuming only 10% of such sites install BAMS, this represents a market of more than $36 million. Since the technology is nearing readiness for integration with DoD platforms, we are currently seeking a commercial partner and other government agencies in preparation for developing a productized device. As for our transition path for the technology, we plan to develop BAMS to TRL 7 or 8 and then transition to low-rate initial production, selling directly to the Navy. If orders for the technology exceed our in-house manufacturing capabilities, we will license the technology to primes. After establishing BAMS on an initial Navy platform, Intellisense will reach out to other DoD agencies to determine who can benefit from BAMS and what platforms can be used. As previously mentioned, Intellisense is currently seeking transition partners and programs of record to sponsor the technology. Thank you for your attention and interest in Intellisense's BAMS technology. If you have any further questions and requests, feel free to reach out to our business and technical contacts listed on this slide.